Yeah, good morning, students, and welcome to our YouTube channel. What we do in this channel is that we bisect and make mathematics easier for you to understand that you cannot get in any other channel. Now, today we want to look at calculus under the topic differentiation. And the question goes, use differentiation to find the x-coordinate of the maximum point for the curve y is equal to x cubed plus 2x minus 4x minus 8. So the first thing is to understand and read the question carefully. Then underline the keywords. Here we are told to get maximum point of the x-coordinate. Now, and the polynomial that we are given is this. So that means the first thing is to understand what we mean by gradient function of a curve. Gradient function. Class, what do you mean by gradient? What is gradient? Basically, gradient means the slopiness or steepness of a line. The way a line steeps or slopes. Does it steep or slope this way or that way? Or, that's what we call, that is what we mean by gradient. Now, for example, if you have a Cartesian plane and then let's say that you have a quadratic curve, for example, y is equal to 3x squared plus 2x minus 4, then that means that you cannot get the gradient of this curve, the whole of that curve. But you can get the gradient of this curve at a certain point. So that means you need to get the gradient function of this curve. Then if you know the value of x, then you can, the value of x, or when you know the coordinate, you can now put it to get the gradient at a certain point. Because the way this point steep or slopes is not the same as here, So you can only get the gradient of a curve at a certain point. You can only get the gradient of a curve at a certain point. So that means that when you are given a question like this, then the first thing to do is to differentiate that polynomial so that you get the gradient function of that curve. But before we look at this, if you're given y is equal to x raised to n, then you want to differentiate, then the dy, which is the change in y over change in x. Remember, gradient is equal to change in y over change in x. But here I'll be using a dy over dx to mean change in y over change in x. Simply, this is how you differentiate to get the gradient function. You take n the other side, then x, then that n you minus 1. That's how we differentiate, so that you get the gradient function, which is the dy over dx. So gradient function will be in terms of x, the other side. That's why we call it the gradient function. Now, before we look at this question, and in case you are watching this channel for the first time, please take a second or two, click that subscribe button so that the next time we produce a video like this, YouTube will automatically notify you. Now let's go back to business. So the first thing here is to differentiate this polynomial and say the dy over dx is equal to, let's differentiate because now we have seen how a function can be differentiated. This is going to be 3x squared plus this should be squared plus 4x minus 4. So you don't differentiate. When you differentiate, this one is 2x, but when differentiate 4x, you get 4. But we don't differentiate a constant. We only differentiate variables because that is where there is changes, the x and y, but not a constant. So this is now the gradient function. But another thing, class, that you're supposed to take note is that at a maximum or a minimum point, the dy over dx is equal to 0. So where the curve is turning, where the curve is turning, be it a minimum point or a maximum point, the gradient at that particular is 0. So the dy over the x, class, you can take note somewhere else that at a maximum point or a minimum point, the dy over the x is equal to 0. So since we wanted to get the maximum point, that means we are going to equate this gradient function with 0. So we have 3x squared plus 4x minus 4 is equal to 0. So this is now quadratic, and you know how to solve quadratic. You can use the use of perfect square. You can also use the completing square method. You can also use the use of a quadratic formula, or you can also use graph to solve that. So can we now use this method very fast? That's two numbers that when we add will give us 4, the coefficients of x, but the same number, if it is cubic, then the value of x must be 3, value of x's must be 3. I hope you know that one, class. So can we now get the value of x? So x is equal to -2, or x is equal to 2 over 3. So that is the value of x. But now you can also get the value of y by just substituting the value of x in the initial equation here and get the value of y. But now we want to test, because we don't know whether the value of x that we are told here, this is 2 or -2 or 2 over 3. We don't know which one is maximum and which one is minimum. So we want to test whether -2 is the maximum point of x, or 2 over 3 is the maximum of the x coordinate. So in testing, I want you to be very attentive. Be attentive here, class, that we test with the value of x and the gradient function, which is dy over dx, and then diagrammatic representation, because that is now what is going to show us how it slopes, whether the point is maximum or minimum. Now, so can we start by testing -2? So you put that -2 that you have inside, just in between. Then you look at the number after -2, and then you look at the number, you take the number before -2. Yes, so the number after -2, when you use the number line, this is 0, this is 1, this is -1, -2, -3. So a number after -2 is -1, and a number before -2 is -3. So can we now use the dy over dx so that we get the value of dy over dx when x is -3. So here, when x is -3, here is going to be that is going to be, let's get it, substitute when x is -3, that's going to be 9. 9 multiplied by 3 is 27. 4 multiplied by negative, that is going to be -12 minus 4. So 27 minus 60, you get 11. So dy over dx here, when it is -3, is 11. When it is -2, dy over dx is going to be 0. When it is -1, then this is going to be, dy over dx is going to be 3. Let's wrap this anyway. When the value of x is -1, then -1 squared is 1. That is going to be 3. That is 3 minus, that is going to be, when it is -1, then squared, that is 3. When it is -1, that is going to be -4. Then -4. So it is 3 minus 8, which is -5. So that is -5. So in diagrammatic representation, this is a positive, so it goes up. Then this is 0, it levels. Then it is going down, which is a negative. It's going down. That is how you're supposed to represent it. And you realize that this is now a maximum point. When it goes down that way, because when it reduces, then 0, then positive, then that is a minimum point. But when it goes up the way just example, the one that we have gotten, then this is a positive 0 level, then going down, that is a maximum point. So that means x is equal to negative 2 is at a maximum point. So that means we're 2 over 3. When you test the 2 over 3, then you are going to get, this is going to give you a minimum point, but negative 2 gives you a maximum point. So when you go back to the question that use differential to find the x coordinate of the maximum, so the x coordinate, the maximum of this point is negative 2. And this is how we mark it. If you differentiate this one, we're giving you method 1. If you're solving that one also, we give you bonus 1. And if you're getting the values of x's, we give you another bonus 1. Then it was 5 marks. Then if you're getting, you're testing your coordinate also, we give you some bonus 1. Then if you get negative 2, we give you answer 1. Yeah, so it's very easier as such. And thank you so much for listening, students. And let us meet in our next class. But before I leave you, I want to give you some assignments so that you go and do. Now, assignment is use the first principle to differentiate this polynomial here. Use the first principle to differentiate this polynomial function here. Use first principle. Thank you so much and bye-bye.